The key was created for one service to call another. It went into an environment variable, then into the deployment templates, then into the continuous integration settings, then into a developer's laptop for debugging, and eventually into a support ticket where someone pasted a log. It had no expiry, it worked from any address on Earth, and it was 3 years old. Nothing about that story involves an attacker being clever. So let's look at how services should prove who they are to each other, and why the answer changes the shape of the system rather than just the format of the credential. A shared secret is a bearer credential, which means holding it is the entire proof. There is no second factor, no notion of where the request came from, and no way for the receiving service to distinguish the real caller from anyone who has obtained a copy. That would be tolerable if copies were rare, but the lifecycle guarantees they are not. The secret has to be present wherever the code runs, which means the deployment system, the build pipeline, and usually a few laptops. Then rotation, which is the one control that would limit the damage, is exactly the thing this design makes hard. Changing the secret means both sides changing at the same moment. So rotation is a coordinated release with a rollback plan, and it competes with feature work. It gets scheduled, then moved, then quietly dropped, and after 2 years everyone treats the key as permanent infrastructure. The vulnerability is not the secret. It is that the architecture made the safe operation expensive. The way out is to stop distributing identity and start deriving it. A workload is already running somewhere that knows a great deal about it, which image it is, which account it runs under, which namespace and node it landed on. That platform can attest to those facts, and an identity service can check the attestation and issue a credential in return. The service never receives a long-lived secret because it never needed one. It proves what it is by being what it is and gets a certificate valid for a short window. This is what workload identity means in practice, and the important word is short. Because the credential is issued on demand rather than configured, its lifetime can be minutes. And once a credential lives for minutes, an enormous amount of security machinery you previously needed simply stops being necessary. Consider what a short lifetime changes. Revocation, which is genuinely hard in distributed systems because every verifier has to learn the news, mostly stops mattering. A credential that expires in a few minutes revokes itself faster than any revocation list could propagate. Rotation stops being an event with a change request attached and becomes something that happens continuously in the background, which means it actually happens. And a credential that leaks into a log is a curiosity by the time anyone reads it, rather than a breach. Notice that we did not make the credential harder to steal. We made stealing it far less valuable, which is the more reliable move, because you can control how long something is useful, and you cannot control every place it might end up. One piece remains, and it is the one that removes the network as a security boundary. With certificates on both ends, you can use mutual TLS, where the client verifies the server and the server verifies the client. Now a connection carries a verified identity for both parties, regardless of which subnet it came from, and being inside the network grants nothing at all. Keep the second question separate, though. Mutual TLS establishes who is calling. It does not decide what that caller may do. And collapsing the two is how estates end up where any authenticated service can call any other. Authorization is a policy about which identity may reach which service and which operation, evaluated per request. Identity is the input to that decision, not the decision. Everything here is a small piece of a much bigger shift, from trusting a network to verifying every request. The Cybersecurity Architecture series covers it properly, including workload identity in detail, certificate lifecycle at scale, and how policy is enforced at runtime without every team writing their own. That is where to go next